Okay, this video is on cloud forensics. Now, your textbook doesn't really cover a lot of cloud forensics, so this is going to be the primary source, or at least the starting point, related to cloud forensics. So, what is cloud forensics? It's basically what we've already been doing, but we are using a service provider instead of having, for example, on site hardware. These cloud providers, the three most common are Amazon AWS, which stands for Amazon Web Services, Microsoft Azure, and Google GCP, which stands for Google Cloud Platform. There are a number of other cloud providers, but like I said, these are the three primary ones. Now, some of the things are the same, some are different, and I'm going to list some of the challenges here. The first is lack of physical access. These resources are in a data center somewhere, and you will not have physical access like you would if this was your own hardware. Data volatility. What I mean by that is there are things like contents of memory, etc., that are lost when a power is removed from a machine, or in some cases, like the contents of /temp on a Unix machine may be wiped out on reboot. So it's much more likely that you will be spinning up and down machines that are at a cloud provider's location way more than you would if you were housing those machines physically in a data center at your location or company. And since when you own machines, those machines are in the same state, for example, that you are doing your work, that is most likely not true in the case of cloud providers, or is way less likely to be true. So there may be jurisdiction and legal issues that you have to think about or deal with when you're doing an investigation. Now, we collect evidence and logs in network forensics. Cloud forensics do the same thing. Some of the things that you might be wanting access to or to preserve are operating system logs. These would be inside the VM and would be very similar, or probably exactly the same, as if you owned a machine that was running the same operating system that you're running in the cloud. There are a lot of application programmatic interfaces. There are logs for API calls. For example, there is AWS CloudTrail that keeps track of that. From a networking standpoint, there are flow logs. VCP flow logs, for example, is the name, again, in AWS. And applications will have logs as well. Now, if you're doing things with on-site machines, the applications are probably running on a particular machine, and therefore the logs are in or on that machine. In the case of a cloud provider, especially if you're doing software as a service, those application logs may be somewhere else, and you will not have access to the physical machines to log in and grab those logs. So you would have to depend upon the application logs that the cloud service provider thought were appropriate and make available to you. As far as evidence creation or collection in the cloud, we can snapshot disk and then go back and run some type of disk forensics on those. We can try to capture VM memory. This is going to be a little more difficult because you do not have access to the hypervisor. The hypervisor being the software that emulates the various components of a machine. For example, the hard drives, the memory, the network connections, etc. In the cloud, we have things referred to as object store or blob storage. We may need to collect data from that. AWS made popular S3, which stands for Simple Storage System, I believe. That is how they make data available to you, typically through something they call buckets. As far as network forensics in the cloud, what we're going to have access to is going to be the VCP flow logs, which I mentioned a moment ago, and the NSG logs. NSG stands for Network Security Groups. So this is probably going to be the closest equivalent to firewall logs that we have in the cloud. We have network security groups that control access and what's allowed to pass and what's not allowed to pass. In the cloud, we often have load balancers, which is we have a connection point for one, let's say, application. But on the back end, there are 3 or 4 VMs that might be providing that service. So load balancing is switching between multiple machines to give you typically the fastest, most reliable access to the back end machines. Virtual machines, you should be familiar with that. Containers are something like Docker containers, where you have all the software and data you need in a container, and then you use an application, for example Docker, to instantiate and run the contents of the container. So the logs will be in the container. In some cases, when the container goes away, changes to the file system, changes to logs, etc., may be lost. So it's going to be much more difficult to get those as compared to a traditional VM. In these cases, you need to focus on the compute level evidence. Ephemeral instances basically means when it shuts down or the instance goes away, changes are lost. They're ephemeral. As far as storage and object forensics, there are access logs for your storage that you could look through. If you turn it on, there are versioning and recovering. So if something changes and it was a bad change, you can go back to a previous version and hopefully get to a working / more consistent state. And deleted objects can often be recovered. So if a hacker got on and deleted a bunch of stuff, you should be able to recover those. And a lot of cloud providers have data exfiltration detection. Again, data exfiltration is you have a huge database or a huge file system that has information that a hacker might desire. They've compromised your system and now they're copying a lot of data off the system. So there are ways to detect that and at least tell somebody they should look at it to make sure it is legitimate. Huge amounts of data flowing off the machine or out of the storage system. Timeline reconstruction in the cloud. This is not necessarily a trivial thing when you're talking about a physical machine or a VM that you have full control over. You will need to collate more things in a cloud environment. We talked about API calls. You will need to look at those. There will be network logs and system logs that you will need to collate. Now, some of the challenges is, since these are different machines, possibly in using different time servers, or maybe not using a time server, you have to deal with time synchronization. And also, you may have multi-region activity. For example, at the University of Kentucky, for the longest time, we were only using US East, which is in Virginia. We have started using as our second region Central. So those are in 2 different time zones. So they're off by an hour, and you need to remember that and account for that when you're building a timeline. Now, as far as some tools, these tools may be provided by the cloud provider. For example, AWS has something called CloudTrail and GuardDuty. Azure has Monitor and Sentinel that can be used to do forensics. There are third-party tools that you can buy, such as Autopsy. You have to buy the cloud data option. And we talked about this before when we were talking about memory forensics, but volatility can be used in a cloud environment to look at or capture memory. And then there are log analysis tools such as Splunk or Elk that could be used. So that was a relatively short introduction to cloud forensics and how they're the same and or different as traditional digital forensics, and some of the concepts you need to know related to that.